Very good morning, students. Well, last time I have shared with you the two videos on this basics of integration. Okay, now we will be taking a third one. It is also the something revise what you did in previous classes, and later on we will take some applications. Today I want to discuss with you two concepts. Number one is the fundamental results on integration that are frequently used in tackling the big integrals having integrands of different types. And second is I want to discuss with you the substitution method. Okay, let me start with this formally. We have two important formulae. Fundamental formulae, I will say. Fundamental formulae. First one is integral of fx raised to power n into f dash x. This will be f of x raised to power n plus 1 by n plus 1 plus c. Here also we use the rider n is not equal to minus 1. We cannot put n minus 1 because it becomes it does not converge. Whatever function you have here, fx, excluding this power, we have to see is this function the derivative of this fx. If it is the derivative of this fx, then you have simply this integral equal to this one, fx raised to power n plus 1 by n. Then you have second formula, which we can again deduce from this if we put n is equal to minus 1. We said it is not defined for n is equal to minus 1. The answer for n is equal to minus 1 will be clear to you by this. If you have integral of f dash x by fx dx, that is where numerator is derivative of denominator. When numerator becomes derivative of denominator, in such cases, what is this? This you will remember, it is log of the denominator, log of fx plus c. It is log of fx plus c. So remember these two formulae. You can have also the proofs. If you ask me proofs, I can give you the proof. Is very simple. Proof is very simple. If you go to proofs, you see there, if we take this, we know that derivative of f of x raised to power n plus 1 by n plus 1, whatever the constant you have here, with respect to x, this comes out to be n plus 1 into f of x raised to power n. Internal derivative of fx is f dash x by n plus 1 as it is, and constant derivative is 0. And this is now derivative of fx raised to power n plus 1 by n plus 1 plus c. With respect to x, this comes out to be only f nx into f dash x. It is this fx raised to power n f dash x. So by definition of integral, this means that integral of f of x raised to power n into f dash x dx is nothing. It is your right side, this fx raised to power n plus 1 by n plus 1 plus c. This is how we find out this. Okay. You can also have the proof of the second result. Suppose you have derivative of log of fx, log of fx plus c with respect to x. How you find out its derivative? Derivative of log fx is 1 by fx. Then numerator, in numerator you have to write down, it is log fx here, sorry, it is log fx, log of fx 1 by fx, derivative of fx is f dash x plus 0. Doesn't this mean that integral of f dash x by fx dx is log of denominator, log of fx plus c? Okay, so you can remember these two formulae. I have also given you a little bit proof of this, so you will also put it in your formula list that you will do in future. You see where we can apply it. Suppose I have sometimes I come across an integral like this. It is under root of it may be integral of 1 by under root of 1 minus x square. Say it is sine inverse cube dx. I have to integrate it. It seems to be very difficult. It looks like different, but it is nothing. You can write it. It is this integral of sine inverse x whole raised power minus 3 into 1 by under root of 1 minus x square dx, like this. This is your fx. This is your n. This is f dash x, derivative of sine inverse x. So it takes the form this integral of fx raised power n into f dash x dx. This is what? Fx raised power n plus 1 by n plus 1 plus c. Sine inverse x cube minus 3 1 by x. The derivative of sine inverse x comes this. So I can write according to this, it is nothing. It is sine inverse x raised power minus 3 plus 1 by minus 3 plus 1 plus c. So this is minus 1 by 2 sine inverse x raised power minus 2 plus c. So you come across questions like this, but later on you will tackle these questions more easily by the method of substitution. Method of substitution is then very easily to apply in all such cases where you have fx raised power n f dash x or f dash x by fx. You can do it by substitution. So let me discuss what is the substitution, integration by substitution. Then we will have some application part. We will have some application part. You can then apply. You will see how substitution method works, how it helps you in many problems in integration. Okay. Now what is this substitution method? It is integration by substitution. I should write integration by substitution is best word. It is integration by substitution. Integration by substitution. Let me give you an example. Suppose I have to integrate here fx into gx dx. Integral I is this. Actually I will share with you, there is no hard and fast rule to integrate a function by substitution. Substitution के लिए कोई हमें hard and fast and fixed rule नहीं है. It is when you apply the substitution method, you have to just look into this function. You have to see which function is the derivative of second function. You follow this way. You have the product of two functions here. One is fx, another is gx. I will write if one function can be expressed, as derivative of second one, then substitution method is applicable. When you just introspect the function integrand, sometimes you see that this gx happens to be the derivative of fx, or fx happens to be the derivative of gx, or in other words we can convert the fx as the derivative of gx or gx as the derivative of fx when you find one function is the derivative of another. Suppose if you have, say, gx looks like the derivative of fx, what you do is you put you put fx is equal to new variable, say z or t, whatever it is, new variable. And there is the theorem on this, that when you make this substitution like that, it gives you f dash x dx is equal to dz, because you are differentiating. It is the differential calculus. In differential calculus you have this theorem. I am applying that theorem. When we make the substitution, it is the variable x involves, this involves variable z. I am differentiating this this side with respect to x, this is f dash x, this side with respect to z, it is 1, derivative of 1, z is 1, it is with respect to z, it is dz. Okay, so I have, if this is now f dash x is gx, so that means you can write, you have found g of x dx is dz. So what you do, you replace this gx dx by then dz, and you replace this fx by z. So variables are changed. Variables are changed. You can integrate them by substitution method. This is what substitution method says. Very simple. You did it in your class 12th, and I am again giving you it is a review how you apply it. Let me have some problems on this substitution method also, so that this is clear to you. There are some integral questions which look like very difficult to solve, but by substitution method we can crack the integrals in very easy form. Let me have a question like this. Again I will try. I have a question, say it is integral of tan I is integral of tan inverse x raised to power say 5 into 1 by 1 plus x square dx. There are two functions in the integrand. 1 by 1 plus x square cannot be expressed as a derivative of tan inverse, no, but tan inverse is the derivative of 1 by 1 plus x square. So in one glance, this I come to know that tan inverse x is the derivative of, in this tan inverse x, tan inverse one function, this is derivative of this. This can be converted as the derivative of this. Let us make the substitution, put tan inverse x is equal to t. So when we differentiate, is 1 by 1 plus x square dx is equal to dt. Now you see how your integrand gets reduced into single function and simplest form. This is I is equal to integral of tan inverse x, this is your now t raised power 5. Okay, then you have 1 by 1 plus x square dx, it is your dt. So this is now simple, and variable get changed. It is now the integrand in t. You can integrate this. It is t raised power 6 by 6 plus c. You can write it 1 by c. Give the value to t back. It is tan inverse x raised power 6 plus c. Okay, this is substitution method, and previous two results that I have quoted, they are the fundamental results. By we can tackle those results. We can also do them by the substitution. Now substitution, you would say, in other words, it is the remedy of many problems in mathematics. Okay, let us have some problems, more problems on this. I have taken the list of problems here that you can do. Let us first do this. You have the let me take questions like this. Suppose you have to integrate 1 by x log x square dx. How will you proceed? This you can write 1 by x log x to dx. This way also you can go. This you can write log x raised power minus 2 1 by x dx. If you make the substitution, put log x is equal to z, This comes out to be 1 by x dx. 1 by x dx is dz. You see how the integrand gets now reduced. Log x, it is z raised power minus 2. 1 by x dx is your dz. You can integrate this now. It is z raised power minus 1 by minus 1 plus c. This is minus 1 by z plus c. This is minus 1 by z is your log x. So it is how you apply these. Let us have one more problem here. Suppose you have a question like this. This is the integrand. Dx by, it is x, log x, log x, then log x. This question looks to be very difficult, but if we want to solve it by substitution method, we go this way. If we put this log of log x something, by differentiation I can get 1 by log x, 1 by x. This part I can get. But what about this part? If I put log x, the derivative of log x gives me only 1 by x. It is this. What about these two? If I put this, I will get this, not this. Now otherwise, if I put log of log x something, I get this easily. You see how? If I make the substitution, put log x is equal to t. Do you know how to differentiate log function? The shortest method is log finish 1 by the function. Log goes 1 by the function. Then derivative of log x in the numerator. Because what is derivative of log of fx? Log fx. Yes, I will just review you. What is derivative of log of fx with respect to x? You know it is 1 by fx. Then you write differentiation of fx with respect to x in the numerator. Similarly, we will go here. When I differentiate this, this is 1 upon log of log x. Then this function, its derivative will go in the numerator. Derivative of log x with respect to x dx, because we are differentiating this with respect to x, dx is equal to dt. Okay, it is 1 by log of log x. Now I differentiate this again. Log of log x, this log will go. This is 1 by this function. It is log of the log function. So this will be 1 by log of x, this log x. Then derivative of log x in the numerator. It is 1 by x. Okay. Here derivative of this is, this log will get cancelled. It is 1 by this function, and derivative of this function in the numerator. Then here when you differentiate this log will get cancelled. Derivative, this is 1 by this function, that is 1 by log x. Then derivative of log x is 1 by x. And what does this? It is with respect to x. With respect to x. This is what? dt. So you get 1 upon x log x into log of log x dx is nothing, it is dt. Therefore, this integral I, you can write now, this integral I is how you proceed this. I can rewrite this integral now. This integral I will rewrite. I can write it 1 by x log of log x dx, and in the numerator you have log x. You have put log xt. This comes out to be, and this is derivative 1 by x log x. It is dx is dt. So it is simply dt by t. You have put this t, it is derivative, you have got this thing. So this is dt by t. What is integral of dx by x? Log x. Dt by t, log t. So it is log of t plus c. Now you replace the t value back. What is this? When you replace the t back, come here, it is I equal to log the value of t. I will replace. What is value of t? It is log 3 logs log x log x plus c. It is the integrand. So integral of this comes out to be this log x. Otherwise this looks like very difficult, but it is not. When you use the substitution method, you can tackle many integrals in shortest way, provided you have a vision. You see here, one thing is very important. It is your differential calculus, differentiation, because you must know which function can be converted as the derivative of another function. Whose derivative you can convert, put that equal to new variable, you will get the integrand will be solved. Okay, I will wrap this. I will give you one more application to make the things easy to you. Okay, let you have one more application here. Suppose you want to integrate, it is cot x by log of sin x dx. It is this. If we differentiate cot x, we won't get log sin x. Maybe if we put log, let us make the substitution, put log of sin x is equal to z. When we differentiate log of sin x, what is this? 1 by sin x, then derivative of sin is in the numerator, cos x dx is dz. Derivative of log of sin x, 1 by sin x, derivative of sin x in the numerator is cos x dx dz. This comes out to be cos by sin. It is cot x dx is dz. So your given integral is converted into short form. Cot x dx is dz, and this log sin, it is z. Okay, again integral of dz by z, it is log of z. This you can write, it is log of, what is the value of z? You put it log sin x plus c. So this is your log sin x plus c. This is the integrand. Okay, let us have one more example here. I will have one more question. Suppose you have I integral of sin 2x by a sin square x plus b cos square x dx. Yes, how we deal this? How shall we deal this question? You see, when we differentiate sin square x, it is 2 down sin x cos x sin 2x. If we differentiate cos square x, it is 2 down cos x minus sin x. So derivative of sin square x is sin 2x. Derivative of cos square x is minus sin 2x. In both cases we get here sin 2x. So therefore we have to convert one. Either we convert this cos square in sin square or sin square in cos square. We can write it this way. You see, I can write it integral of sin 2x dx. Okay, this is a sin square x plus b, this cos square I can write y sin square x. This on simplification gives you sin 2x dx. Then this is a sin square x minus b sin, take a minus b, this will be a minus b into sine square x plus b, simple. Or you can also write in terms of cos, no problem. Cos square. You see now the suitable substitution is here, because when we put this sine square into new variable, its derivative is this. So suitably I can go put sine square x is equal to t. What is this? 2 down, it is 2 sine x, then derivative of sine is cos x. This is your dx is equal to dt. This is sine 2x dx. You have got dt, okay? Sine 2x dx is dt. Therefore my integral comes out to be it is reduced now, integrand gets reduced. It is dt by a minus b t. A minus b, this is t plus b. How I integrate this? This is integral of dt by b plus a minus bt. This is again 1 by f dash x by fx form. If you differentiate b plus a minus bt with respect to t, you differentiate I don't need it. You see this comes out to be, it is integral of, if it is integral of dt by b plus a minus bt how I proceed? F dash x by fx form I can go. If I differentiate b plus a minus b into t with respect to t, what is this? A minus b. So here it should be a minus b. I can go this way. I will write 1 by a minus b into integral of a minus b dt by b plus a minus b t. It is your fx, this is your f dash x. Derivative of this is a minus b. So this is fx, f dash x, fx, f dash x, fx. This is log of the denominator. 1 by a minus b, it is log of b plus a minus b t. Clear? This is now, it is 1 by a minus b into log of b plus a minus b. It is derivative sine square x, your t plus c. This is the solution of this integrand in short form. Clear? This is how we use the concept of substitution. You can use the concept of substitution again and again. Previous problems what you did in the previous these lectures. Okay, let me have one more application here. It is, the question is here, it is this. You have to integrate integral of a raised power x log x plus n x raised power n minus 1 by a raised power x plus x raised power n dx. This is the problem. How will you tackle it? You see, if I differentiate a raised power x, what is this? Exponential function, a raised power x, as it is differentiation of power 1 log of base log a. So the derivative of this is simply this. If I differentiate this, what is this? N down x raised power. It is simply like integral of f dash x by fx, direct dx. Your f dash x by fx, isn't this? So you did the formula. When you have f dash x by fx, what is it? Is integrand. It is log of denominator, log of fx plus c. So you can write it is log of, what is now fx? Log of ax plus x raised power n plus c. This is how you do these problems. So two fundamental terms or results on integration: integral of fx raised power n into f dash x dx, which was fx raised to n plus 1 by n plus 1, and integral of f dash x by fx dx. We can also tackle those problems by substitution method. Okay, so this is something on substitution. I will come with more applications, more problems on substitution method. Is now clear to you when to use substitution. I have already told you there is no hard and fast rule, but rule is if you come across the integral of the product of two functions in such a way that one function can be converted as the derivative of second or is directly the derivative of second, we can easily use the substitution method. It is for both. For lower classes, 12th class, you can use it there, and for higher classes, you can use it there also. So this is something about these two results that I have shared with you. Some students were asking me through WhatsApp that what about exact differential equations, then Clairaut's form. Now after this, when this becomes clear to you, the basics of integration is clear to you, and application of integration is clear to you, and when we reach the this differential solution of differential equation, ordinary differential equations, and there I will deal the exact differential equations and Clairaut's form. Don't worry, I will this share the videos with you so that your difficulties get clear. There is no problem. Goodbye. I see you next. Thank you very much.